Hello, everyone, and happy Thursday. I'd like to welcome you all to the fourth episode of our Lunchbox Leaders Cybersecurity Unfiltered series. I am going to be your host today. My name is Derek Geisler. I'm the sales director for PGH Networks. I'd like to thank everyone for joining today. Just to get a few things out of the way before we get started, like the other events that we've hosted, the first 50 people who have joined the event today will receive a Grubhub gift voucher. If you, for any reason, don't receive that gift voucher, first things first, please check your spam filter. And if for some reason it is not in there, please reach out to our marketing team at marketing@pghnetworks.com, and they will get you all squared away. We have a really great event today. At the end of the event, if you're able to stay till the end, we will be raffling off another fun prize. It will be a Ring floodlight camera with an Echo Dot. So that should be a really fun prize for somebody to set up at their home. I wanted to thank everyone for joining both this event and our previous 3 events in the series. I hope you've really gotten some value out of it. The purpose of these events when we first put this together was really to educate the community on different ways to protect yourself in today's cybersecurity threat landscape. So thank you again. And, I hope you've gotten some value and you've enjoyed these events. Today's event is going to be a really good one as well. We've got Ben Verscharen with Sophos. Ben is the Global Solutions Engineer, and he's coming to us from just outside of Melbourne, Australia. So, I think it's around 2 a.m. there right now. So Ben's been burning the candle at both ends. Ben's going to be talking about artificial intelligence and how it plays a role in cybersecurity. So I wanted to go ahead and hand over the reins to Ben. Ben can give himself a quick introduction. As with everything else, if you do have questions, please post the questions in the Q&A, and I will do my best to ask the questions during the event, and then we will have a Q&A following Ben's presentation. So Ben, it's great to talk to you. Really excited to hear what you have to talk about today for artificial intelligence.
Thank you so much. I really appreciate it, and thank you everyone for joining today. As Derek said, I'm Ben Verscharen, and I'm a Global Solutions Engineer at Sophos. It's interesting, I've been asked to do a lot of different events recently. I actually primarily specialize in the threat landscape and offensive security techniques. So, breaking into organizations, I run a freelance pen testing consultancy as well. And that's generally all of my exposure. And when it comes to talking and being at different events, everyone's like, "Oh, do something about COVID. The new norm, remote working, threat landscape. What does it mean for us?" And I don't know about everyone else. I'm finding that a little bit desperately dull and done now. So what I wanted to do today was, talk about AI and why now. And really explore beyond the buzzword of AI, because, in my travels, not that I've done a lot this year, though I've been doing a lot of virtual roundtables and speaking with executives in all different countries all around the world. This term AI is just being thrown around by everybody, and I think it's starting to lose its relevance or meaning, which is actually incredibly sad, from my opinion. So I want to go beyond the buzzword today. Interestingly enough, last time I actually did a presentation on AI was in Japan last November. It was to a technical audience. I had live translators. They're used to actually working not with Australians, so the poor Japanese translators had to hear me talk technically about artificial intelligence and then translate it live to an audience. So it was quite the experience. So I don't think we need a translator for me today. Hopefully we don't. I know I do talk a little bit funny, but let's get straight into it. So why are we talking about AI now? What's the purpose behind it? Well, firstly, let's look at the news. And there's AI sells, let's be honest. AI is sexy, or was sexy. Interestingly enough, in the news recently, though, we're seeing more negative than positive when it comes to AI. And this is very much instilling doubt or trust with people when it comes to artificial intelligence, which is quite sad for such amazing technology. So we saw an article, I think it was Bloomberg that first published it, and it was about, you know, fraudsters using AI to mimic a CEO's voice. And of course, as every headline does now, when this article was published, it was shared on social media. Groups like BuzzFeed got it, rewrote it themselves and shared it around, and all of a sudden, you know, people were starting to talk about doom and gloom, how bad artificial intelligence was, that it was going to take over the world. I actually caught up with some old high school friends at the start of the year, and we're at a pub, and a good friend of mine, Squeak, hadn't seen him for years, and he starts talking about, you know, all the bad things to do with AI, and pretty much talking like AI was going to be the downfall of the human race. And today, I'm going to really explore why that's actually not the case, and why I don't think we're ever going to end up in such a scenario. But then on the other side of the coin, you know, the headline I've got here about the black hat talk that caused a huge uproar. In fact, some people got ejected from Black Hat in Las Vegas last year when they actually called BS on the presenters from this company, Time AI. But this company, Time AI, claimed that they had come up with, you know, encryption algorithms that were pretty much impenetrable, unable to get broken. They were creating true randomness, which is something that's incredibly difficult to do. But they called themselves Time AI. And why do you think that is? Well, much like the fraudsters, you know, claiming to use AI to mimic a CEO's voice, and that's selling papers and headlines, this company, Time AI, was playing on that buzzword, playing on that hype, and trying to build their company about venture capitalists investing and everything else based on having AI in their title and paying for sponsorship slots and that kind of thing. So AI isn't going to take over the world anytime soon. It's certainly not the Terminator, but AI sells. It's generally sexy, though it's starting to get burnt out due to people abusing these buzzwords. So we can say, you know, what's going on in the world? Well, one of the reasons why AI has exploded is data. Believe it or not, the thing that actually drives artificial intelligence, neural networks, machine learning is data. And one of the things that's absolutely fascinating is the fact that data is influencing some pretty amazing open source projects and initiatives. For those of you on the call today that use the social network site Reddit, or the news site Reddit, I don't know how it's they call themselves nowadays. They call themselves the front page of the internet. But data is what drives neural networks. And this is why we're all of a sudden seeing this huge rise in artificial intelligence. Like a great example of this is I saw on Reddit recently, someone created a neural network to detect cancer. And of course, this has made headlines all around the world. So how does someone at home come up with a way to, say, detect a tumor, for example, a cancerous tumor? Well, it comes down to open and anonymized data sources, and you know, companies like Google have actually done a really great job of releasing data sets, and you can download data sets to train your neural networks with. So once upon a time, if you ask someone to download 150 gig or more of, say, images to then analyze on a dial-up connection, you certainly couldn't do it. The storage costs on the internet to share that kind of information wasn't possible, and to collate that information wasn't possible. But here in 2020, and you know, the last couple of years, compute's cheap, bandwidth is high, and storage is cheap. So to share information, to actually train neural networks, has become incredibly easy. So as I was talking about earlier, like things like detecting cancer, well, it's really easy to now go and obtain, say, anonymized images of say, what a tumor looks like when it's cancerous, what a benign one looks like, that kind of thing. So obtaining data is incredibly easy. And you got to look as well, like groups like Facebook. Like, why is Facebook worth so much money? They don't have any revenue from their users. Well, they get it from their ad network, but also the new gold in, you know, this day and age is data. So they're of course selling their data to other companies that are, of course, then training AI engines or neural networks on, different behaviors and people, and, even using it to analyze people's a language so they can understand based on, say, a user's profile and the language that they're using, what kind of person they may be. So data is what's really driving neural networks now. But of course, we can't go past software and hardware. And I actually want to talk about this a bit more in the next page. But like NVIDIA, for example, just released a new graphics card. I think it's the 3080, and it's super expensive. It's like $1,600 US for this card. But why does it suddenly have so much value? Well, the gamers want it, the crypto miners want it. But if you're a computer science or a student or a data scientist and you want some hefty compute, something that can process huge amounts of data in a short period of time, well, with consumer grade hardware now, you can certainly achieve a lot. And we'll talk about that a bit more in a second. But even if you look at NVIDIA as a company, one of the top banners they have on their website now is artificial intelligence. And NVIDIA as a company even have a podcast now that is just about AI and everything that they're doing as a company around AI. So there's just a consumer trend that's driving this, and the barrier to entry is no longer supercompute. It's what can you buy off the shelf and put together in a weekend. But of course, we can't look past the success in other domains. Like in my driveway, I've got a 2017 Skoda Octavia, a nice car, a European. I'm not too sure if I've ever seen one when I've been traveling in the US, but my car has the ability, and it cost me less than $40,000, has the ability to do things like read street signs, detect collision, look out for, things like kangaroos and stuff like that jumping across the road. So like all these object collisions and determinations based on speed, my attention at the wheel, so how much I've been moving the steering wheel in the last couple minutes, the car's able to make decisions on whether I'm going to have a collision or not, and of course preempt it and brake for me, stop the car for me. It makes it incredibly difficult for me to even veer out of my lane if I'm feeling a little bit lethargic on a boring highway. And of course, companies like Tesla with the full automation, well, what's powering all of that? It's all powered by AI. So this, other domains like automotive especially has, of course, brought more people into the industry and caused an explosion of things like artificial intelligence. And if we look at, as I said earlier, like software and hardware, it's just become easy to do. If you look on the right-hand side of my slide, I've got the neural compute stick here. This is something that Intel created for people that want to get into data science. So the neural compute stick that's up on screen is literally the size of a USB thumb drive, something that you can carry around in the pocket. And that was actually designed to work alongside a cheap like Intel NUC or a Raspberry Pi. And we're looking at as little as, say, $200 US. You're able to have yourself a nice little development framework that can process huge volumes of data using the neural compute stick. And of course, once you've got that prototype ready to go, you can then ship it off to the cloud and use a service like Amazon or Microsoft Azure to then run your production algorithms or develop that algorithm further. And what do? Well, they bill by the minute. So you're paying cents on the minute for, say, an AI instance or a compute instance that can then, of course, roll these algorithms that are being created into production. There's open source libraries like TensorFlow, and with that, TensorFlow is used alongside most commonly Python, the programming language. You can import data, tell it what that data is, and then of course these algorithms in a very short period of time can start making accurate predictions. And we look at even just shared knowledge. So the book that the cover that I've got on the left-hand side of my screen, that's a book written by our chief data scientist and one of our senior data scientists, Hilary Sanders. And that's on exactly how to write an algorithm to detect malware. I've personally bought this book myself. It was, I think, $20 on Amazon. And at the end of this book, I wasn't just visualizing and looking at malware. I was able to create a neural network to detect malware myself. So the barrier to entry from a cost perspective is super cheap. the knowledge is out there now for anybody to start exploring these domains. So then the whole question becomes, well, how do I apply this? What can I do with this knowledge that I've obtained? So to give you a bit of an example, I'm going to run a video. It might not come across too well with the shared screen and the fact that it's traveling many thousands of kilometers, but hopefully you can see a few snippets of it. So this video, I'm going to show you real-time computer vision. So a computer watching a clip from a James Bond film and built this algorithm was trained on $2,000 worth of hardware. So incredibly cheap barrier to entry here. And as I roll the video, you can see in real time, or hopefully you can see all these different boxes quickly identifying a chair, a person, a motorbike. We know how fast these James Bond films are actually moving. If you go and watch that scene in real time, you can understand and identify that, like within milliseconds, this algorithm is able to see a tie, a motorbike, a car, any object that's on screen because it's been trained to do so, and on consumer grade hardware. So this barrier to entry for AI is so low that all of a sudden we've seen this explosion in this buzzword AI, and it's selling. Please.
So just a question though, if somebody was to get into this and try and do that similar functionality 10 years ago, let's just say 10 years ago, and try and do those same things on that video, what was the barrier entry back then in your opinion? You know, I mean, how much money were they looking at?
Tens of thousands at a minimum. Like the graphics processing has come a long way. You know, I go back to 10 years ago, cards were cheap. They only had a couple gig of memory, so you'd probably need multiple graphics cards at a minimum. Cloud compute 10 years ago, I don't know about you, Derek. I wasn't having conversations about AWS or Azure and their online GPU and compute 10 years ago. In fact, they were pretty much just ideas. I don't think Azure existed 10 years ago. I think AWS may have. So
well, to bring it down, to kind of bring it down to like day-to-day real world scenarios too. I mean, companies like Amazon, right? They're using tons of AI and automation in order to, you know, get those packages delivered to you in 24 to 48 hours, right? I mean, a lot of that is just built completely and solely on AI. I mean, you know, the efficiency that it's bringing to all different industries, that's really the value driver. And I don't think it's taking away jobs. I think it's just changing the way we're doing things. Would you agree?
Absolutely. Let's bring it back to the medical example earlier. I wouldn't want a computer to tell me if I've got cancer or not. Honestly, I know this is a bit of a dark place to take it, but it's a great example. Like we've seen so many neural networks created that can predict quite accurately if someone is ill or not. So if we look at the medical space, are we going to see pathology and radiology disappear? Well, no. What we're going to see is maybe a quicker way to go through results to say, well, 100% chance that's benign. Let's ignore it and tell that person they're fine. The doctor looks at it quickly and says it's fine. So another one might have a probability of 80%. This looks bad. Of course, let's go look at that more thoroughly. So I would never look at AI as competing with a human. I would look at it as complementing or enhancing human capabilities.
Absolutely. I think enhancement is probably the right word for that, right? I mean, you know, and I'm sure you're going to get into it from a security perspective, but, you know, with all the threats that are happening today, the human capability, it's almost impossible, right? It's almost impossible to be able to basically protect against all the threats, you know, so I think you have to say that it's an absolute enhancement.
Yeah, it's absolutely necessary. And I'll actually show in a moment the breakdown of how we make a determination with ML for malware specifically. But, you know, I've heard stories, Derek, and it's fascinating hearing some of the labs, people that have been around for a long time. Customers used to put a malware sample on a floppy disk and send it to our labs. It could take 1 or 2 weeks to get there. Would write an identity for it. And that would be valid, would send out the identity to all of our customers via CD or floppy disk. And that was good enough protection because there was only a handful of malware variants and it was such a small space. But now, you know, our Sophos Labs alone sees about 500,000 unique malware files every day. So
500,000.
500,000, yeah.
I mean, 500,000 a day. That's just, it's absolute insanity to think that, considering where we were with signature-based attacks, even 5 years ago.
Yeah, and so think about this. Like, one of the things I find fascinating is some people say to me, "Oh, look, I don't really like, protection technology that talks back to the cloud because, I don't want an analyst to look at my document." Like, just playing those odds alone, for an analyst to actually look at, say, a sample submitted into a labs or a virus total or anything else like that is quite small. In fact, if an analyst sees your document and a human ever opens, say, something that was submitted up to labs for analysis, you may as well go buy a lottery ticket.
Yeah. Yeah, that makes a lot of sense.
Yeah, but of course, using things like AI, we're enhancing our labs, and I should have actually put a slide together on it, but let's talk about it now. Like, if we think about it, like, there's malware families like Stuxnet that we probably saw samples of that pass through our labs back when Stuxnet was attacking centrifuges in Iran. There was some samples that probably got out there and never got looked at. But one of the ways that we're able to enhance detection capabilities is by applying algorithms to say, well, tell me what looks different. What's something that's probably malicious but looks different? And maybe that's where an analyst should set focus to. So we're actually using AI not just to make a malicious or benign determination, but in our labs, we're using it to actually say, okay, well, let's try and funnel the right information to people. So maybe we can find that next ATP, that next group out there that's been hiding in the shadows and not being detected yet. So there's so many different applications for it.
Yeah, that's super interesting. I mean, just really, it's like, hey, this is what's coming, right? These are the things that we should be concerned about potentially, and using AI to basically determine that. That's amazing.
Yeah, and it's what you have to do. Like, with such huge volumes of data now, like, how else are you going to consume it? It's really the only option.
Yeah.
So, like, moving on from there, like, some people treat AI as this black box, this big mystery. Some people don't like talking about it, and that's really bad. Like, I was in Dubai last year with our chief data scientist. We were on a 4-wheel drive trip, and of course we were going through the dunes in a 4-wheel drive, and of course we were talking about malware and data science. I'm actually ashamed to actually say it out aloud now because it sounds so nerdy. But like, one of the things he said is, like, when we're looking at a company to acquire, or when anybody's looking at technology, you should be able to ask the question, well, how does your ML or how does your AI actually work? Tell me what you're doing under the hood to make these determinations. And it's pretty relevant when you talk about it, because if someone just says, oh, we got AI, trust me, we can detect any threat, it's like, well, actually, how are you doing that? Because you're accountable for the decisions you make. If you're an IT decision maker and you buy a product just because it's got a buzzword on the label and don't know how it actually makes a detection, what's going to happen when, say, malware slips past the new defenses because you bought, say, a new cybersecurity startup and it had all the buzzwords on the tin that got you excited and said, well, I'm going to partner with these guys or girls because they seem to know what they're doing. But of course, the neural network might not detect, say, malicious Office documents. Or, it could just be trained purely on based on detecting malicious executables. So you need to be able to ask the question, well, what are the capabilities of this product that you're trying to sell me? Tell me more about it. And this is where I'm trying to lead you today, is to certainly question and query what's going on in the back end, because you've got the right to know. You want to know how you're actually being protected. You don't want this mythical or mystical box to determine your fate and your organization's fate.
Yeah, and it's interesting because we've gone through, we at PGH Networks, we use Sophos almost independently, like for pretty much everything. And we're huge fans of the Sophos application. But I mean, we have done our due diligence in looking at all the different applications and all the different product lines. And it's amazing the different approaches that each product takes. And there's positives, there's different kind of niches, if you will, for each product and each manufacturer and each approach and each, attack vector protection, if you will. Some are network based, some are file folder based, some are, so it's like you are correct. You really have to be cautious You have to ask those specific types of questions to better understand, what they're protecting, so that, we're big fans of building a layered kind of protection, if you will. So if you don't know what each tool is doing to protect you, you can't really build a layered approach, because there's going to be holes and gaps. So yeah, just it's very interesting. I totally agree with you. Just a lot of different ways that people are approaching this.
Yeah, and it's actually really fascinating you say that. Like, you said layered defense, and one thing that endpoint protection does is, like, it's a layered approach. Like, one thing you need to understand with AI is it doesn't talk in absolutes. It talks in probability. So, for example, if we see a file that's signed by Microsoft, we've seen it many times before, we know that it's legitimate, we're not going to touch it. We don't need to worry about that unless it starts exhibiting malicious behavior, of which that's a conversation we'll have in a moment. But if we get a file come through and it comes in at 80% probability that it's malicious, or 70% probability that it's malicious, well, we could either convict it there and say, well, there's 70% chance it's bad. But if we convict it then, what's going to happen? Well, we've made a prediction. We've said that it's bad. We've blocked it. The user then says, well, this was a legitimate app. It was made by Adobe, so it probably looks bad. I probably shouldn't have said that, but I'm down that rabbit hole now. So, it's made by Adobe. It probably looks bad, but it's not. I need it day to day. So what do? Well, we say, well, it's at 70% probability of being bad. We've made the prediction that it's probably malicious, but let's go through and triage it through our other engines. Let's flag this one. Let's say, okay, well, we're going to allow you to run, but let's treat you with a little bit more caution until we're absolutely positive that this is a good file and it's not going to harm the user. So we can even just use AI as a point of triage. So we don't need to talk in absolutes there as well.
People that aren't in the industry and aren't in cybersecurity, if you will, don't really understand a lot of what you're talking about from a 70%. Like, they don't understand, like, well, this application, I've used it before, you guys put this on, now it's not working. It's like, well, yes, it's because we're just not sure if it's, the application, we don't know if it's valid or viable yet. So we tend to like to be a little bit more cautious and then loosen the reins, right? As we get more comfortable with these different applications. And really, that's in the best interest of the business that we're trying to protect. And people kind of lose sight of that because they don't understand that how much is involved in actually protecting them on a day-to-day basis, and so we see that a lot. And, have to make adjustments, have to, sometimes make apologies to say, look, yeah, this is a legitimate application, but, we're just being cautious.
Yeah. And obviously we want to take that. We don't want that service ticket to ever get created to say, can you unblock this app? So we do every effort we can to say, okay, well, 70% chance it's malicious. Let's triage it before we actually upset the user and make them,
Sure.
Make the admin then have to go and release it. So you're spot on there. User experience is just as important because the last thing you want is, especially people on the call today with developers that want to turn off their antivirus, just go and Google, a few different breaches like the RSA breach and say, well, I think my developers actually need antivirus on there. So we need the user experience to be as seamless as possible so people don't start disabling protection, because chances are the person with disabled protection is going to be the one that ends up in absolute strife. So
that's kind of the real security, the sauce in security, right? It's not just protection. It's that blend of protection and then that actual end user experience, right? So how can I protect, but also allow you to have the proper applications and tools in order to do your job successfully? That's really the sauce, right?
Yeah, you're spot on. And like we talk about this all the time internally, generally not officially, but like, when we're catching up, it's like, well, we could detect everything. We could detect every bit of malware if we actually wanted to, but we're also going to make a lot of mistakes along the way. Do we want to do that? Like we could tune an algorithm to be horrendously aggressive. We could set a threshold to be incredibly low. But at what point do you say, well, you're actually a hindrance to our operation, and the total cost of ownership is incredibly high? So that's where we triage and try and make it as seamless as possible. So
Love it. I love it.
we better move on because I'm getting concerned about time, but
Okay.
that's okay. Hopefully you're all enjoying the horrendous accent that I have and aren't struggling to understand me too much. But as I move on, like one of the great examples of how we're applying AI is the neural networks that we've created for what we're calling our next gen web protection. Because you've probably all experienced a web filtering engine that primarily relies on, let's say, the URL to say, okay, well, have we seen it before? Do we have a category for it? And that's really common. If we go back even 10 years ago, a lot of web categorization and filtering was actually OEM databases from a few big vendors that then we would supplement with. We don't do that anymore. But these big vendors that used to OEM lists and sell it to everybody else, and when I say OEM vendors, they're names you would never heard of before because they only sell to, say, web proxy and filtering companies. But they used to hire like college and university students and find cheap labor to say, well, here's a list of websites. Can you just go to that and classify it for us? And eventually their database just grew and grew and grew. But we know now that, URL filtering has progressed a long way from there. We've got some demos on our microsite that I'll share at the end that you can go and have a look at if you're interested. But like one of the other things is, having a look at the content on the web page. And I'm not talking about just images, but the way that language is used in the HTML. What does the HTML look like? So as we talked about earlier, it's about triage. And here we're not just looking at one neural network, we're applying 3 or 4 neural networks to then correctly categorize and potentially block a website. And I want to show you what that looks like. So here I took a screen cap of a gambling website. Actually, I can't remember the domain for it, which is a bit annoying. It is 2:30 a.m. for me, so do forgive me. But if we look at it, we've given it overall classification scores. And of course, the higher the score, the more likely, so the closer the score is to 1, the more likely it is that we've made an accurate determination, or the probability is much higher. So the overall score for this site, for example, we've determined that it's a gambling website. The URL score itself, though, we determined was 0.13, which is incredibly low. The image score on it too, you can actually see is 0.29. So again, 29% probability that it's a gambling website, which makes sense because it's only got pictures of phones. You can see we actually rated it. Sorry, I accidentally clicked. We actually rated the images on the site safe. There's nothing wrong with these images, and that's the one that came in at the highest. The URL score actually for this one's interesting. It came in at 76% for alcohol and tobacco. But then the final determining factor that really skewed the stats here was the HTML on the website, and the language that was used on the website made us come back with a very high probability, almost 90% probability, that this is a gambling website. So what does this mean for us as a company? Well, it means that using neural networks, we can use our existing database to say, well, we can make a quick determination whether it's gambling, and if you're a school, we're not going to let you go to it. Or, it's adult content, we're not going to let you go to it. Or if we're unsure if it's a website that's never been seen before, like websites come and go really quick, especially with services like, not just Amazon, but like Sites and Stores and Squarespace and similar. Website, a URL we've never seen before, how do we categorize it? Well, we can now apply things like neural networks to come up with a determination. A great example here actually is this website Cold Steel. And it's fascinating, like we've given it a 73% chance that it's a weapons site. It's not even close to any other website, but the URL score again for coldsteel.com is only 47% probability a weapons site. Now, I don't know how it's come to the determination that Cold Steel refers to weapons, but it's got to that level. That's a question for a data scientist. Sexually explicit, 28%. I'm surprised to see that, but okay. And as we go down, the probabilities of it being anything else is quite low. But the image score I love here because it's absolutely, it says, well, 74% chance this is a weapons website because you've got knives on the homepage. Of course, we're going to make a determination on that. But then look at the HTML score. It's got the highest rated score of 99% probability this is weapons. Why? Well, read about it. It's knives, swords, machetes, tomahawks, spears, and more. If that doesn't tell you that it's a weapons website, I don't know what would, Derek. Honestly, mate. So,
sounds like a weapons website to me.
yeah. So, and this is what we're able to do. It's absolutely awesome. So moving on from there, we talked about malware in great detail. We will touch on it again in a second, but the other place we can go to and move on from is a behavioral detection. So we know that malware isn't just a binary, although we still see a lot of binaries that gets onto a computer and runs. It's, it's not the Trojans of old. Like one of the most common things that we see is now, macro-enabled Word documents. Yes, it's 2020. We're still talking about macro-enabled Word documents, but we also see these trends of like living off the land. So, an attacker might manage to get remote code to execute on a system. It's a really good position to be in as an attacker. So when you get remote code to execute, that means that you've generally got some form of connectivity back to that host so you can send it any command you like. Now, as an attacker, and I can speak with a lot of experience here, as an attacker, when you first get connectivity onto a system, you run a bunch of enumeration and you try and find the weak points, the vulnerabilities that may exist within that particular system, and trying to find some weaknesses in configuration. What did the engineers or what did the IT department screw up? But then you've got this trend of living off the land, which is using legitimate applications. So for example, there's an executable in Windows called sc.exe. S for Sam, C for Charlie. That stands for service control. Now, SC itself is like used by any system administrator, any admin that's been around for more than a couple of years has probably definitely used service control at one point in a script or manually. Now, service control is amazing because if you can find a service that has got weak permissions, you can get service control to say start writing web shells or malicious code into services to get them to execute and say add persistence. We can go down a bit of a technical rabbit hole here, so I'm going to stop there. But living off the land is using things like service control, trusted system administration tools that you would expect to be on a system, and abusing them, getting them to run malicious code for you. So when it comes to what we're doing from an AI perspective, we're of course not just looking for these malicious binaries, but we're using a wealth of information that comes from our data lakes, our MTR team, so our managed threat response team, malware infections that we've seen or attempts of infections, even what we've found in binaries to say, let's abuse this system tool so it looks legitimate. And we're using these tools, tactics, and procedures to then train the algorithms to say, this is what abuse looks like. And this is a very, very powerful way to complement AV to say, okay, well, it doesn't look normal. Let's do something about it. So, and then of course we can go through that triage process. So we apply AI to known anomalies, and it's a great way for us to then make a determination or detection. Now, it wouldn't be a security presentation to, of course, talk about phishing, and everyone still gets phished, and it's amazing to see the failure rates for phishing. I know that when I do penetration tests, when a customer asks me to put a phishing simulation in scope, I cheer because I know that at least I'm going to be able to say, well, I found a problem and it's with your users. Let's do something about it. Let's educate your staff. It's pretty much a guaranteed win for a cyber criminal when it comes to phishing. And the thing is, phishing is cheap, phishing is easy, and that's why we see it all the time. We've even seen phishing become regionalized. Like Australia, we've got 26 million people, although we consume a large amount of space, and we even get like targeted phishing attacks just to Australian residents. And next door neighbours in New Zealand, there's only 6 million people there. they have targeted phishing campaigns just against them. And of course, and there's the global ones. You're probably well aware of the campaigns you see in the US, a lot to do with United States Postal Service. Surprisingly, pharmaceutical scams are still high in the US as well. But anyway, we won't go down that too much of a rabbit hole. But phishing has always got the same kind of tactics to it. And it really comes down to things like urgency. An attacker wants to send an email to you and they want to try and emotionally manipulate you to click on that email as fast as possible and to do something as fast as possible. So one of the things that's amazing with AI is this natural language detection, looking at language and understand the emotions behind it. I was at a talk by IBM at the Australian CyberCon in December last year. I was presenting there and I sat in at a talk that IBM did. And IBM have got some amazing tools, and one of them was the SIM engine. They wrote an AI engine, and by analyzing people's language in their emails, they were able to predict within very close accuracy whether they were close to resigning, whether they were unhappy in their job, that kind of thing. And language is a huge part of who we are and how we communicate. Of course, it's not just all body, but text as well. It's amazing what text can tell. Now, as humans, we're actually not as good as machines when it comes to detecting emotion sometimes behind language. And of course, with phishing, now that I've said it, you'll probably start noticing a lot more that phishing attacks ask you to do something urgently and quickly. And there's a few reasons for it. The biggest one is the command and control infrastructure normally gets shut down very, very quick. So there's a chance that if you sit on a phishing email for 24 hours and go and click on that phish, the link's going to be dead. The site's been taken down, they've been discovered, and they've moved on to the next scam. So that's why we see this emotive language. So based on this evolution of natural language detection within AI, we've of course come up with ways to determine whether something is malicious or not. So I'm going to play you this little video that our chief data scientist put together, and you can see that he's got, the email here, dinner tonight. Hey baby, what are you doing for dinner? And based on that, it's going to come through and it's going to put together all these different probabilities that we've seen earlier. Now, of course, at the moment, it's not that bad. We don't think anything of it. But as you start to then change, say, the email subject to urgent request, and you start to change the language in here a little bit more, the scoring is going to go higher and higher and higher to the point where it's like, well, yeah, this looks bad. We should definitely triage it further. Being mindful of time, it's almost over, so we'll allow it to run through. But you can see that as Josh goes through and he puts a different language in here and keeps submitting it for new scoring, the urgency is going higher, the attachment scores going higher. And based on that, like I said, we might not be able to make a quick determination whether it's malicious or not, but we'll at least know that we can triage it and do more with it. Because your boss might send you an email also to say, hey, this is urgent, you need to do something. But you got to think, if you apply threat intelligence and how we've detected spam for the last 20 years, along with something like machine learning and this natural language detection engine, then our prediction on whether it's malicious or not goes through the roof. So I don't know if you're noticing a trend of everything I'm talking about. It's about prediction and complementing what we've been doing for years. So this is why AI is so powerful and why it sits in everywhere. And of course, Derek, we were talking about this earlier, like we want our ML engine when it comes to detecting malware to be interpretable, understandable. So we give our customers the ability to visualize, to understand that thought process, how we made the determination whether it was malicious or benign. And this is actually really cool. So we in our sandbox, Sophos Sandstorm, and using our APIs that there's actually a free tier for on Amazon. You can submit samples to Sophos Labs and quickly get back our determination. So you can see here that we've ran a sample through, and the verdict was that our overall machine learning analysis came back that it was malicious. The feature analysis came back that it was malicious. combining different features together came back that it was malicious. The structure of the file came back that it was malicious. And of course, the file reputation was malicious. So like here, we've made an absolute determination, but you can actually see the thought process of how we came to this determination. If you look at the feature analysis in the bottom left-hand corner of my screen, you can see that we've gone through, we've identified different features of this particular file. And for example, this particular file, if we look down the very bottom, we've got the bar graph where it says may have dropper capabilities in current version run. So what this is actually doing is saying, well, based on a random sample set of malicious and benign files, more often than not, so in this sample case, 952,000 files had this malicious trait, or a malicious file had this trait, and only 432 legitimate files had this trait. So this gives us a pretty good probability that this is malware. It straight away starts pushing that probability to the malicious side. And as you start combining these different features together, you can then see, well, based on everything else that we've observed, based on, 35 years of intelligence, the likelihood is, of course, malicious. And even when it comes to files and reputation, we can do a lot with that. The genome type and, comparing similar samples, we can actually say, well, looking at the code in this particular sample, it actually matches other samples, and based on that, we know it's bad on, malicious or benign. A great example of this is the Maze ransomware group. When we analyze the code and the genome behind that particular file, we can actually directly attribute code that's in that sample with malware samples that go back with like Ryuk and some other malware families. So what that actually gives us is not just whether it's malicious or not, but that's one of the ways that we can actually piece together to say, well, the Maze group, Ryuk group, I think it was Ryuk, and other samples that we've seen all the way back to 2008 is all the same threat actor. They've just evolved from, say, a crypto miner to a ransomware family, because that's where the money's at the moment. So we can use ML to also identify code bases, discover similarities, and of course, piece together and try and figure out who these cyber criminals are, which in my opinion is crazy fascinating.
Absolutely. It's basically they're going to repurpose anything that they can so they don't have to rebuild new stuff, right? And they're basically piecing all those different applications together, and it's kind of like a signature, if you will, like they're kind of like their thief signature, if you will.
Yeah, you're spot on. Yeah, like I said, it's super cool. Like for any threat researcher to be able to visualize that. The thing is, when you're looking at code, there's often artifacts that might indicate who the person is. But so Maze, for example, is a very popular ransomware group. They're the group that exfiltrated 10 terabytes of data out of Canon a couple of weeks back. So by identifying that there's similar code traits there, if they're the same people, we can look at samples back in 2008, for example, and say, right, well, they weren't as experienced there. Maybe they left some traces of who they were in their old malware. Let's go back and analyze that and see if we can do some correlation and figure out who the people were. So there's a lot to it. And of course, moving on from products and being very mindful of time that we don't run over, being able to visualize these features from an analyst perspective, and here's a great visualization. This is like thousands of malware samples that have been grouped together by those features I had on the different page. And it actually gives the analyst like a virtual realm to go back and say, all right, well, I want to look at the groupings, the similarities, and of course, try and hunt these threat actors, which is exactly what we were just talking about, Derek. So there's some amazing technologies and applications from visualization and everything else when it comes to AI, and how Sophos is, of course, applying that to detecting threats. So looking at threat protection, I say going forward, some of this is implemented today. One of the things that we also do from an AI perspective is when we've got a new model, we don't just put it into production and say, off you go. We often run it in parallel, say for email, to say, okay, well, this is our results with email. In parallel, we were scanning our customers, and this was the results from a determination perspective from a, Sophos protection with ML bolted in there as well. So that way we can see over, say, a 3 or 6 month period, how we would have gone from a false positive rate, from a detection rate. Would it improve? Would it diminish, based on the models that we've created? And then we can either go back and tweak it if it's not the results we want, or we can say, cool, this is production ready, and then of course cut our customers over. The thing is, this is just standard threat protection and prevention for Sophos going forward. So, we don't release a new model and say, you know what, it took us 6 months to train it, we're going to up your price by $6 a month. This is just an expectation and an innovation that we're doing, that we roll into our products when they're production ready. So I'm not going to go through every single detector that we've got here, but things like our Android APK detector. APK is the application package for Android. Like, that's been detecting huge volumes of malware on Android devices. It's absolutely phenomenal. I kind of demonstrated what we're doing from a malicious URL perspective, but of course we're continually working to create new neural networks. And this is what I was talking about earlier. If someone says to you, yeah, we've got ML, trust me, it's like, well, how are you applying it? Because as you can see here, we're having to create models for different scenarios, and would expect that our competitors are having to do the same thing. So, for example, I think it's actually been rolled into production now, but when I created this slide, our Microsoft Office neural network wasn't ready. It was still in development. We know it's working, but we haven't rolled it out there just yet. But so if you were to ask Sophos, well, how are you going to detect in malicious Office documents? We would say, well, this is how we do it now. This is how we're going to do it in the future. So make sure you verify what people are spinning you and telling you, and try and look beyond that AI buzzword. So that actually rolls up for me. Hopefully it's been an insightful session and an interesting session. There's my details on screen at the moment. I'm not directly a part of our data science team, but I work alongside them. They're publishing all of their work at ai.sophos.com. If you want to go and have a look and have a bit more of a read about what I talked about today, look at their DEF CON talks, their Black Hat talks, and similar. It's all online, ready and open for you to consume. And of course, ask me any questions in the QA now that we don't have a lot of time, and send me an email if you like. So thank you all so much, and thank you, Derek, for hosting.
Absolutely, Ben. Thank you so much for your time. So a couple quick questions that I wanted to ask you. I mean, this was absolutely fascinating. We're kind of nerding out a little bit, right? Being in the industry that we're in and loving tech, but to bring it kind of down to people and businesses, from an artificial intelligence perspective and just from a security perspective, you had mentioned that people should really be looking at, how their applications are, using artificial intelligence to protect them. But what else should they be, in your opinion, what else should businesses be concerned about, and what type of applications should they be looking at in order to protect them?
It comes down to knowing where your risks are. Like if you're using something like whitelisting, you don't allow. I know organisations now that don't allow attachments from the outside. They're like, well, we don't share data with the outside, and we shouldn't have customers emailing us zip files and Word documents. It really comes down to identifying where your holes are and where your risks are, and of course finding the solution to plug the gap. But like I said, like AI isn't necessarily going to give you that 100% determination. It's going to just complement the detection. So I wouldn't be turned off if someone said, oh, look, we actually don't have AI and a neural network to detect this particular thing, but this is how we do it. So what I'm getting at is understanding your risks and where your potential vulnerabilities are, and then trying to seek a solution that properly fits that. So don't get excited by the buzzwords. Don't get excited by whatever Gartner's talking about, not to devalue Gartner for the record. That's a career limited move. But, looking at what you actually need to protect and where your risks lie. And then, of course, just finding the solution that best fits your problem. That's
an absolutely fantastic recommendation. I mean, like you had mentioned, if email is not really a threat vector in your business, right? You're doing everything over the phone, or you're doing it other ways. Email is probably one of those low risk attack vectors. So you need to focus on other ways, right? And it could be anything from firewall to some type of cybersecurity, cloud-based cybersecurity application if you're really cloud-based, even down to physical security, right? So you have a lot of walking traffic, you have a lot of that type of stuff going on, and you want to use AI to help you with cameras and things like that from a physical security perspective. Just really looking like you'd mentioned, looking at those different ways that you need to protect yourself, right? And that's going to be different for every business. And I think that's the important piece is, from our perspective, we want people to know that you need to partner with somebody that understands that each business is going to be different, and it's not just a one size fits all for security. So thank you for this presentation today. It was absolutely fantastic. Is there anything else that you wanted to add as we kind of wrap up here?
No, I think that's all for me. Like I said, check out the microsite and of course sophos.com to have a look at everything else that we offer. But yeah, thanks everyone again. I really do appreciate the invite to talk today. Yeah, thanks again, Ben, and go get some sleep. I'm sure you're overdue for some sleep. I'm actually wired and excited. I had so much fun, so I'll probably stay up for another hour and regret my choices in the morning. So I like it. Awesome. Thank you so much. Oh, you're welcome. Thank you. No worries. So Ben gave us a fascinating presentation on artificial intelligence. It truly was amazing. And really the point of that is really just to give you some information on what the backside of your security entails. It's a lot of people just really don't understand, how this stuff works. And I think giving you a little bit of the backside of this really helps you to learn, different ways to protect yourself and what is actually happening in your security protections today. So throughout this series, we've talked about layered security in a number of different ways to kind of protect yourself. The first event we had Microsoft talking about how to protect the Microsoft infrastructure, which is the majority of, a lot of what businesses are using today, right? So that's things like two-factor authentication, increasing your secure score, those types of applications. We had ID Agent come in and talk to us about how passwords suck, basically, and how to basically protect yourself and kind of keep an eye on yourself from a dark web perspective, if something does happen and your password does get leaked. And then Blackpoint came in and talked to us about, if things do sneak through the door, right, they get through the middle of the goalie's legs, right, how they're going to kind of watch your back and protect you from that perspective, right, and the different ways that they're going to do that. And then Sophos, just to round it out and talk about, with all the protections that you have in place, how artificial intelligence is going to lend to that. So it's been a really fascinating series, and I really hope everybody has enjoyed it. I want to thank, Nicole Murtha, our marketing manager here at PGH Networks. She's done a fantastic job putting these events together. I'd also like to thank the team at Spark Design. They're our marketing company that we work with, specifically Mackenzie and Liz over at Spark. They've really done a great job. Behind the scenes, they're producing these events with Nicole's help. It's been really fantastic. So with that being said, I think it's time for the Wheel of Names. So as I had mentioned before, we are giving away a fantastic prize. It is a Ring floodlight camera with an Echo Dot. So with the artificial intelligence theme in mind, the Echo Dot really does make a lot of sense. So Mackenzie, if you could go ahead and give us a spin of the Wheel of Names, and let's see who's won. So I'm gonna murder this name, but Giles T. de Bordeaux. Thank you so much. We really appreciate you joining our event, and I apologize for possibly ruining that name. It's really sorry for that.
We'll be reaching out to you after the event to get your shipping information so we can send out your Ring floodlight camera with the Echo Dot. So congratulations. I'd like to thank everybody for joining our series. This is the last and final episode of our series. I hope everyone got a lot of value out of the series. We really enjoyed putting it together. And thank you, everyone. And this does conclude the series and the end of the event. Have a great day, everyone. See ya.